Now I'm going to show you how to do stoichiometry calculations. Here's a basic schematic for you. And up in the upper left, you see the quantity. And anytime you have a stoichiometry problem, you have a quantity that's given to you. Now, the quantity given usually has a number connected to it. All right, so it's going to be grams, it's going to be liters. When you're reading your word problem and you're doing your interpretation, look for the thing that has the number attached. All right, then you have to convert that to moles. All right, so when you convert to moles, remember it's going to be through something like molar mass, or it could be through something such as molar volume, that 22.4 liters of any gas at STP. Now, when you do that conversion, you end up with the moles of the material that's given. Now, if you already have moles, hey, be happy, you're in moles. You don't have to do that conversion. But if not, if you're given a quantity, you have to go through the mole to make that work. Then comes the molar ratio. And the molar ratio is simply the coefficients of the balanced equation. Okay, so when you look at a balanced equation, chemical equation, you see the numbers, like, if you have 2 moles of this and 5 moles of that and 6 moles of that, it's simply the ratio of the given that you are given with the number on it, and then the required. So when it says how many grams or how many liters, that's the required. So when you go through the molar ratio, then you end up with the moles of the required. And I'll say required or desired information in the problem. And then finally at the end, you just convert to whatever quantity that the problem requires you to convert to. So, if you're going back over to grams, go through molar mass. If you're going through the molar volume, that's the 22.4 liters. And as we learned in Chapter 11, the mole chapter, you could also go to molecules or particles or ions. And so ultimately you'll end up with the quantity of required that the problem is asking you to find. So we'll get on to some examples on the next slide. All right, so now when we start working a problem, the first thing you have to do is you have to have a balanced chemical equation. You have to look at the problem, you have to figure out what's going on. So how many liters of gas is released when you react 15 grams of magnesium with phosphoric acid? Well, we have to do a chemical equation, so let's take magnesium plus phosphoric acid, PO4. That's a 3 there, by the way. And then, let's see, what are our products of this reaction? Well, one thing, this is a single replacement reaction. So who's going home alone? That's going to be our buddy hydrogen. All right, and then what's our other product? It's going to be Mg3PO4, 2. So magnesium phosphate, and to get a balanced equation, we're going to need, we're going to need a, let's see, 2 here, a 3 here with the hydrogen. That means a 2 here and a 3 here. Now you go back and you look at your equation, basically, or you look at your sentence or your given reaction up at the top, and you have to identify what the given and what the required are. So the given is right here. It's got to be the magnesium is the given. And I usually put it over top of it and circle it, but since I can change colors, I'm just going to put it there. So magnesium is my given. I'll just write it over here as well. And then the required, and I think now I'm just going to put it on the formula. The required, if you look over here, how many liters of gas? Now, the given has numbers associated with it, 15 grams. But the required, how many liters, how much, what is it looking for? And the only gas in this thing, after this is all said and done, we should recognize is hydrogen. So there's our required, and I'll also say it's desired information from the problem. Then what we do is we set up our little dimensional analysis, and we start with magnesium. So we go 15 grams, 0.0, that's our significant figures. Remember, significant figures come off the original information. For every 1 mole of magnesium, it weighs 24.3 grams. Then for every, this is where you get, now if you remember, go back to that last slide that I was talking about. Here's the grams of given right here. Okay, so grams of given are right here. All right. And then now we go to moles, all right? So what we're doing now is converting to moles of the given, all right? And then now we have to do the molar ratio, okay? So molar ratio, and the molar ratio is just the coefficients in the balanced equation. So notice how I'm going to get this to cancel. I'm going to do 3 moles of magnesium here, and then to the required. So that's the moles of the given down below, and the moles of the required is up above. That's so your moles of magnesium cancels. So that's going to give you 3 moles of hydrogen. Remember, hydrogen's diatomic. Okay, so I'm just going to label this a little bit. Here's the moles required, and the moles of the given are down below. Moles given. Okay, now that'll cause it to cancel ultimately. Let me go back over. And then at this point, you have to do your final step. And that final step was to do the conversion back to whatever the problem's asking. Now, the problem specifically asks for liters. So for 1 mole of any gas, you have 22.4 liters of that gas. And that thing is called the molar volume, but it's actually given us that final conversion back to the quantity required. All right, and so now it's calculator time. We want to go with 3 sig figs because our original problem had 3 sig figs. Let's do our cancellation. We have, change this out. We have grams of magnesium going away, moles of the given, that'd be magnesium going away. Here's moles of required going away, and then we are left with the amount, which is going to be liters of hydrogen as our answer. And we run that on our calculator, and hopefully you guys are good at that by now. Anyway, you end up with 13.8 liters of hydrogen. That is your ultimate answer in 3 significant figures. All right, so hopefully that helps you understand a little bit about how to do these calculations properly. I'll do a subsequent calculation on how to do a limited reactant problem. But for right now, this one can get you into various types of mole calculations. Remember, when you look back up at your required, considering we're going through the mole, you could do molecules, all kinds of various things to make this work. Anyway, enjoy.